Today I'm going to present an assignment on convolutional GAN implementation using PyTorch to generate handwritten digits from the MNIST dataset. And I'm going to explore how generator and discriminator networks are structured using CNNs and how the model is trained, and finally how how much actually expected result we can get from 200 epochs, because with larger epochs the result will be much more presentable, but with the lower like 200 epochs is very low for this GAN implementation. But due to the Google collabs, I need to use just 200 epochs for this assignment. And this project is based on the idea of generative adversarial networks, or GANs, where two neural networks actually working as a generator and discriminator and trained together is in the same time. The generator tries to create realistic image from the random noise, where the discriminator attempts to apart real images from the fake ones. What makes this implementation different is that the instead of using basic dense layers like the MLPs, I use the convolutional layers for CNN are better at understanding the pattern of images and more visually accurate outputs, even fewer with the fewer epochs. And do that, I have to import some libraries like NumPy, Matplotlib, Torch, import Torch Vision. Also, I have to use the device GPU. And now I'm going to start with the generator. Actually, I passed here the 100 dimensional noise vector through a fully connected layer and reshape into a feature map of shape like 128 into 7 into 7. Then I apply upsampling twice, each followed by the convolution and batch normalization. And the final layer uses the 10H activation to scale the output between -1 to 1 and matching the normalized pixel range of MNIST data set. And the discriminator is a binary classifier actually, and it starts with two convolutional layers, that is stride 2, and each downsampling the images and applying dropout to prevent the overfitting. The final output is a single value between 0 to 1 and representing the probability that the image is real. And here we use the sigmoid, so Likerelu. And there is a hyperparameter of dataset. Use the latent dimension 100, base size is 64, epochs is 200, change from the 10,000 to 200. And I set the sample interval like 20. After every 20 epochs, I'm going to save the result, actually visually track the progress. And for training, we use the MNIST dataset from the Torch Vision. Each image is normalized to a range between -1 to 1. Previously I told that. And the training loop, I have already told that 200 epochs, and the real image from the dataset and generate fake images using random noise. And I train the discriminator to distinguish between real and fake images. Then I train the generator to fool the discriminator into thinking that fake images are real. Now I want to talk about the output. Also, I am using the Adam optimizer here with the learning rate of 0.002. Also, BCE loss for adversarial loss. And there is training loop where the present ground truth, train generator, train discriminator. And finally, I'm going to talk about the outputs. In the first 20 to 40 epochs, the image are blurry and random. This is completely actually normal. The generator is beginning to learn the shape of the structure of a digits of epochs 60 to 100. I starting seeing the clear forms of resemble digit like 837. These outputs still have some noise, but the digits are distinguishable. And when the epoch reached to 180 to 200, the generator produces images that closely resemble the samples. It uh, nearly about the smooth edges, more clear digital shape with high contrast. Using CNN allows the network to capture here pattern like curves and edges from the primary image. And I am implemented the this with only 200 epochs, so the output is not very good, but it's actually showing very much effective that we can use as GAN. And this is the epoch from 1 to 200, and there are discriminator loss and generator loss are showing two different columns. And now I'm going to show the outputs of my, this is the fully image with fully noise, and this too is the output screenshot. Also, this is for the first 20. When we goes to 600, we can see there is 7, 3, 8, 9, 6. We can see that number closely. And after 120 epochs, there we can see also some number with uh, very easy way like 3, 2, 1, 7, 8. And when we finally get our final output with 200 epochs, there we can see that there is 8, 9, 5, 9, like different types of digit we can see. Thank you for watching my videos.